Hello everybody and welcome to my video on how to make a Hobbit hole in the Hammer engine. I was talking to a new aspiring level designer and he was trying to make a Hobbit hole, but sounds like he was having a tough time with it, so I figured I'd make a video kind of showing the process on how to make something like a Hobbit hole. I will be using Counter-Strike Source as a base for my creation, which means I'll be using Counter-Strike Source assets. But this can be translated over to any source game that you choose. Also, I will be using a third-party modified version of the Hammer engine called Hammer++. It mostly has some quality of life changes, but also has some really nice additions that are well worth using. But you should be able to just use the regular Hammer engine, and it'll be perfectly fine for following along. That being said, I will link Hammer++ in the description if you choose to download it. So let's just hop in here and create a new file so we can start working on our Hobbit hole. Alright, so the very first thing we're going to be doing whenever we get into the Hammer engine is we're going to be grabbing our three first textures here. So we'll come over here to the right side and hit Browse over here near the textures, and we will type in No Draw for our first one here. No Draw is a special texture in that it's completely designed to help with the performance of our map. Basically, you'll want to start every brush out as a no draw, and then any visible faces that can be seen by the player you'll want to texture in, but anything that's unseen should remain as a no draw texture. I won't get into what this does or how it functions within the engine itself as to why you need no draw on surfaces that can't be seen. Just take my word for it that you want unseen faces of brushes to be no draw. We'll also be grabbing our two famous dev textures, the gray and orange grids. These two textures will help keep the early stages of our creation very modular and very susceptible to change. In the very early stages, it's very common for you to go back and completely rework certain parts of your map, so you want to make sure that everything's as simple and basic as possible when you're first starting out. After that, we'll be creating a platform for us to stand on. You can do that by selecting the brush tool on the left-hand side. And then you can drag a rectangle in any of the 2D grids, although I recommend doing it on the one to the right of your 3D camera, which is the top-down view. And then we'll create ourselves a player spawn and place it on top of this platform. You can create a player spawn by selecting the entity tool, which is right above the brush tool, and clicking on that platform that you just created in the 3D view. The player spawn entity is used to tell the game where you will be spawning whenever you load up the map, but it's also really good for helping you gauge scale whenever you first start building things in your map. You want to make sure that things aren't too big or too small whenever you create things. And the player spawn is a very literal representation of how big you will be whenever you load into the game, which you can use to base the scale of everything around you. Next, before you start, you'll probably want to get an idea of what you want to make. You can do this by just getting some graphing paper and start sketching out an idea of what you want to have, or you can just go Google something and get some reference that way, or you could do a mixture of both, or you could even do neither and just start building whatever you want. Me personally, I like to do the go Google for references. So now we're going to start making the walls to our Hobbit house. First thing we need to do, though, is lower the grid size. You can do that by pressing the left and right brackets on your keyboard, or you can select these icons here at the top left. I personally like working in a default grid size of 8. Some people like to do 16. I wouldn't recommend going lower than 8 for anything that isn't detailing, however. So we're going to make our first wall here. I recommend making the height for walls of buildings as a default of 128 units. That's kind of the default one-story height building. And you can, of course, go higher than that if you want, if that's how you want to design your building. But 128 is a good starting point for keeping buildings within scale of your character. So right now I'm trying to get a feel for scale and just how long I want these walls to be. And then after that, I'm going to copy this wall brush and paste it on either side of the current wall. The reason I'm doing this is because I want the edges of the walls here to sort of taper downwards so that it conforms more to the shape of a hill. So we'll create our rectangular sides here, and then we're going to use either the clipping tool or the vertex tool to get the tapering effect that we want. Now, both of these are very strong tools that can be used to make some very interesting geometry within your level, but if you're not careful and you don't know what you're doing, you can end up making geometry that is really messy and hard to work with. The clipping tool allows you to select 2 points on a 2D grid, and upon hitting enter, it will slice the selected brush piece into 2 separate parts based on where you put those lines. The vertex tool allows you to manipulate individual vertices of a selected brush, but you have to be careful not to make invalid solids, which is something that we'll go over later. As a general rule of thumb, whenever using these 2 tools, always make sure that the ending vertices of your brush always align on the grid, and if they don't, know why they don't align. We'll get a good example of vertices that don't align on the grid whenever we get into displacements later on. I'm just going to take the time here to texture our walls and floors here with our dev textures. And you can see how it instantly helps distinguish the walls and the floors from each other. You can change the textures of individual faces by selecting the texture application tool on the left side of your screen. It will open up a prompt where if you left click on a brush face, it will adopt the texture that is currently applied to it, and if you right click on another face, it will apply that texture onto that brush face. Additionally, you can select other textures from the texture search menu like we did earlier, but I already grabbed our dev textures from earlier, so I'm just going to select them from the drop down. Also, don't worry if anywhere my UI looks different from yours. Those are just some changes made by Hammer++. Now, the first thing that I want to create for this Hobbit hole is the iconic large circular door. So selecting my brush tool, I'm going to go to the right side of the screen and select this drop down where it says block. I'm going to change that to cylinder. In the option below that, you can specify how many sides you want the cylinder to have. I'm going to set mine to 16. You'll want to specify the dimensions of your cylinder in the top down view. For me, I want to create mine as 96 by 96. As I feel that's a good size for the scale of the building that we're going for. You can now rotate your door to face the proper direction that you need it to. If you don't know already, you can select an object in the 3D view. Then you can cycle between resize, rotate, and shift by clicking on the object in the 2D view. 6 boxes along the perimeter is for resize, 4 circles is for rotate, and 4 boxes along the perimeter is for shift, but I never use shift, so don't worry about that one. A very useful option you can opt into in Hammer is setting rotations to only occur every 15 degrees. You can set that by going to Tools, Options, 2D Views, and then checking the box there. If you want to rotate like normal, you can hold Alt while rotating the object to ignore the 15-degree rule, and it will just rotate normally. I'm going to resize the width of this door so that it fits correctly with the wall, and then I'm going to retexture it to the lesser known third dev texture. This is to help further differentiate it from the wall that it's going to be lodged into. So moving forward a little bit, I have moved the door to where I want it to be whenever I make the incision into the wall, and given the house a little chimney. Yay! So now I need to make a hole in the wall that perfectly fits the cylindrical door that I've created. Don't use carve, by the way. So I'm going to use the clipping tool to make vertical cuts along the wall so that we can make a rectangular hole that we can fit this door into. Now here you see me clipping directly at the edge of the cylinder. I actually don't recommend doing this. I recommend giving it a little bit of extra space. I'd say give it about 8 units to the left and the right. Just make sure that has a little bit of extra space to move around. Whenever we make the arches that go around it, it'll make a lot more sense. You'll see I actually changed the dimensions of the hole to do just that. So now we're going to create 90-degree arches that go around the cylinder here. This is going to block out that extra remaining space that should be part of the wall. So in the same way that we created that cylinder, we're going to go back to that drop down and select arch this time around. And in the top down view, we're going to create the dimensions for our arch. For me, it's going to be 56 by 56. When you hit enter, it should give you a prompt to specify the details of your arch. If you're following along and you're making it the same way I am, you'll want to set the number of sides to 4 and set the side width to 4 as well. The wall widths actually get doubled whenever you make 90-degree arches, so if you set the wall width to 4, it'll actually be 8 whenever you create it. So hit OK, and you should get an arch that looks roughly like this. Then we're going to reposition that arch to hug the outer edge of your door. If you notice your arch isn't playing well with aligning itself to the grid, select the arch and use the vertex tool, highlight every single vertex within the arch, and then select one of the outer vertexes, and you'll use that vertex as an anchor to force the entire shape onto the grid. Just be careful that if you move it again normally, it'll likely go back to being off the grid. Then we're going to open up the vertex tool. You're going to take the outside vertexes of that arch and bring them up to make a 90-degree angle. It should look something like this whenever it's done. After that, it's just a matter of copying your arch to the other 3 corners and rotating them around. You might notice that the vertexes on the door and the arches don't exactly line up. I mean, they're pretty close, but they don't exactly line up. I'd recommend using the vertex tool on the door and go through and just make sure that they all line up. Interesting fun fact about arches is that all the vertex points on the arch will always by default land on the grid, where the cylinder doesn't. You'll probably have to knock the grid down a couple values, but if you knock it all the way down to 1, you'll notice that they all do line up. So you can change the vertices on the cylinder to match up with the arch and they'll all be on grid. I also decided I wanted to add a window on the right side of the door. I won't go too much into detail on the creation of this because all the concepts used to create this window were already covered in making the door. If you want to make the window, you can go ahead and try and do it. If not, you can skip it, that's fine. The only thing to really note here is that I actually knocked down my grid size to 4 for the frame of the window because I thought it looked better. You can do it with 8 though, that's fine. In fact, if you're new to Hammer, I'd recommend sticking to 8 as much as you possibly can. I also do just a little bit of interior design within the house itself. It's not a focus of this tutorial, so I'm going to be skipping over it. I really only want to focus on the exterior as well as the displacements that I'm going to use to surround the building. The interior buildings is for the most part pretty fundamental, and it's very much up to your own interpretation of how you want the building to be laid out, so I won't be focusing on it here. The main focus of the interior here is really to just give the door something to open to instead of just the blank void. The only thing here I really want to give credence to is that whenever you're dealing with a sloped surface like this one, and you're trying to resize it, always resize it using the clipping tool, never resize it using like your standard resizing. If you want to maintain the slope, then you need to do it this way. Whenever you clip off one of the sides of a sloped object like this one, it's very likely that the new edge of that object will not be on grid. Now this is totally fine so long as you don't intend to move it around and you have a good idea where the actual on-grid endpoint is, i.e. where it was before it got cut. So for example, whenever I cut this sloped wall, the new edge is no longer on grid. However, this is fine because it's right next to the original slope, and that slope's endpoint is still on the grid. So if I need to do any building around this slope, I can use the original as reference as to where that slope actually needs to be created. It's a little bit difficult to explain with words, but if you're following along with this, try to go ahead and create the roof, and that should hopefully give you an idea of what I'm talking about. Once you're finished constructing your roof and texturing in the inside of your building, head on over to the door and we're going to give it some functionality so that we can actually open it. Select your door and press Ctrl T. Where it says Func Detail, change that to Func_door_rotating. When you hit apply, you'll notice that a circle forms within the center of your brush. This is the hinge in which your door will rotate upon. Move that circle to the side in which you want your door to rotate on. Go to the Flags tab and check Use Opens. This will allow you to open the door whenever you press E. Some other flags you may want to look at here are reverse direction, one way, x-axis, and y-axis. X-axis and y-axis will change the dimension in which your door rotates. You shouldn't need to check those here, but if you're making something like a trap door in the future where you want the door to open downwards, you may need to mess around with these a little bit. If you only want your door to open one direction, you can check one way. And if you find that the door opens the wrong direction, you can check reverse direction and it will open the other way. You can also do some additional sleuthing around in the class info tab. You can change properties like how fast it opens, how far it opens, what sound it makes whenever it opens, stuff like that. So do a quick run through of those and see what you like. Once you're done modifying your door, hit apply. Now that we actually have something in the map that's worth testing, we should get our map ready for compilation. But before we do that, let's make a quick skybox around our map so that the compiler doesn't complain about any leaks. Go browse for textures and search up skybox. Scroll all the way down to the bottom and you should see a tool texture called Tool Skybox. Select that one. After that, create a box that fully encompasses your Hobbit hole. Select that box, right-click on it in the 2D view, and select Make Hollow. Just to be completely clear, this is not a good way to make a skybox. We're just making something quick and dirty so that we can actually get in and test. For a fully complete map, you'd want to have a proper skybox that doesn't have all this wasted space around. Once you're in, check your door and make sure that it opens the way that you want to. If it's not opening quite right, go back and fiddle around with the settings of the door. In my case, the door is opening fine, so I'm going to move on. Next, I'm going to start working on making some displacements around the Hobbit hole. But before I do that, I need to expand out my skybox so I have more room to work with. You can do this by using the vertex tool and selecting all the vertices of one side and dragging them out. Or you can just simply recreate the skybox. Either way is fine. Setting the foundation for good displacements will by and far be the most difficult part of this project. And I'm not going to sit here and pretend to be some expert at using displacements. But I'll try my best to explain my approach to displacements and how you can do it. Just for clarity's sake, this is what the displacements are going to look like before they're turned into displacements, and this is what they'll look like after we've done some sculpting. And before we start working on displacements on our Hobbit hole, I'm going to take us aside really quick on a new file so I can better explain just how displacements work. You can turn any brush that you've created into a displacement. Simply select it, go to the Texture Application tool, go to Displacements, and hit Create. This will turn all selected faces into displacements. And this brings up the first rule about displacements, which is to only select the faces that you wish to turn into displacements. Once you hit Create, all non-selected faces will no longer exist. And this is what you want when displacement mapping. You only want to select faces that you plan on sculpting. Rule number 2 of displacements: displacements can only be 4-sided shapes. Triangular sides, for example, cannot exist as displacements. Rule number 3, make sure that all adjacent displacements are sewable with each other. 2 different displacements can be sewn together, so long as the vertice coordinates for the 2 displacements match with each other. When you sew 2 displacements together, it will connect any gaps between the sculpting of the 2 displacements. This is an extremely useful tool, and you want to make sure that your displacements can work with it whenever possible. As you can see here, these 2 displacements are sewable because the vertices on their adjacent sides share the same exact coordinates. When I move this displacement downwards, however, they no longer exist in the same space, therefore cannot be sewn together. 4th rule, but it's also kind of a suggestion. You want the geometry of your displacements to look roughly like what you expect the end product to be, and you want to use the displacement tool itself as a way to just round out edges and do some fine tuning. So for example, if I wanted to make an upwards hill with displacements, I'd make a sloped piece of geometry to show that intent. This makes the setup for your displacements much harder, but it makes actually working with your displacements much easier, and it helps make sure that everything is sewable. So I'm going to add a 4-sided sloped surface to the center of this pit to show that I want it to go upwards. If I wanted to do that and make sure that everything is sewable, I'd want to set it up like this. Or like this if you want to be more efficient with it. Either way works. And since the centerpiece is going to be adjacent to displacements on all sides, whenever I turn it into a displacement, I can select all these different sides because I want them all to be part of the displacement. After that, it's just a matter of using paint geometry to get the shape that you want. So coming back to our Hobbit hole, we're going to make a sloped brush on the left side of our house. I want the face I'm going to work with to be flush against the ground, so I'm going to use the vertex tool to drag its vertices down to the ground. Another good tip when you're working with weird geometry like this is to have the opposite sides of the brush always equal each other's slopes. So for example, whenever I change the bottom face to be horizontal, I change the top one to be horizontal as well. This can help prevent some invalid solid problems later on down the line. Now I'm going to make a copy of this and rotate it 90 degrees, making sure that the outer top vertices of both brushes connect with each other. Then use the vertice tool to drag out the vertexes to fill in the triangular gap. All the vertices involved have to follow the same slope for the entirety of this section, or else you'll get an invalid solid, as indicated here by the red highlighting of this face. This is one of the added features of Hammer++, and it's very useful for stuff like this. Then do it for the other side. If you've done it correctly, then all vertices for the slope should match. Then create a flat square brush on the top, making sure that it fits snugly within the two slope brushes. Go ahead and find a blend texture that you like. You can do this by browsing textures and searching for blend. Blend textures are special because when a brush gets turned into a displacement, and that displacement has a blend texture on it, you can paint alpha within the displacement settings. This will allow you to paint between the two textures given in the blend. This allows you to make better and more realistic transitions from things like grass and dirt, rock and mud, stuff like that. Next, because we're making a Hobbit hole, and Hobbit holes are built inside of hills, we're going to set up the displacements on top of the house. So take the brushes that you took for your roof and duplicate them directly over the original. Turn the new brushes into displacements and give them the blend texture. Then take those displacements and drag them down so that they share the same space as your roof. You should see a ton of Z-fighting between the blend texture and the roof. To fix this, we're going to go edit the displacements by painting their geometry. Set the paint setting to raise 2 and set the value to 1. Then paint those displacements until none of them are Z-fighting with the roof anymore. Then set the value from 1 to 0 and quickly go along the edge of the house to make sure that there's no gap between the displacements and the roof. I then decide to widen out these edges a little bit. So long as you do it for both sides and the intersecting slope remains at a 45-degree angle, it shouldn't give you too much hassle. Now I want to create a series of shallower brushes that'll act as sort of a walkway up the hill. So I'm going to create a new brush, raise it up with the vertex tool until I find a slope that I like. Now to make sure that everything sews, I'm going to take its adjacent displacement and raise the bottom left vertexes up to meet it at the top of the slope. As you can see from the red highlight, this resulted in an invalid solid. The reason being because this vertex here doesn't follow the slope. Only problem here is, unlike the 45-degree angle one from earlier, we don't have an easy way of getting this one on the slope. So let's undo those changes, and instead of using the vertex tool, let's use the clipping tool instead. Drag a line from the bottom of the ramp to the top, and delete the unnecessary bit. We're not quite out of the woods yet though, because if you've noticed, this isn't sewable, and we can't just use the vertex tool to make it sew. Trying to fix the gap with the vertex tool will only reintroduce the invalid solid. Instead, now we need our ramp to meet in the middle with its adjacent displacement. So let's drag out our ramp so that it intersects with its adjacent displacement, and once again, let's use our clipping tool, but on the ramp this time, follow from one side of the slope to the other, and delete the unnecessary bit. These two displacements are now officially sewable. I'm now effectively going to repeat this process until I reach the top of the hill. I don't really have too much else to add on this, so I'm just going to do a time lapse here. In retrospect, the brushwork certainly could have been better, but this is the solution I came up with on the spot. So here we reach an interesting situation. If you recall our displacement rules from earlier, we can only have four-sided displacements. So the question here is, what do we do whenever we get to the top of the hill? For example, if you see here whenever I try to clip this into a triangle, it straight up destroys the displacement, turning it back into a regular brush. Well, it's a little hacky and there's probably a better solution for it, but this is how I managed it. First, I lowered the slope of the hill by 1 so that there's still room for a fourth side. We can now complete this section as normal. I will now create my final wall piece for this hill. I'm now going to use the vertex tool to drag the bottom 4 vertices down into the side so that it matches the slope of its adjacent wall. Finally, I'm going to use the clipping tool to shave off everything except for the top 8 units of this new brush. Of course, this leaves the bottom vertices off grid, but we have ways to deal with this. Create a flat brush at the top of the ramp and use the clipping tool to cut off the side of the brush so that it matches the slope of the wall it's adjacent to. This, while still being horribly off grid, is still completely sewable with all adjacent displacements. And that's the important thing that we're looking for. After that, all that's left is to connect those displacements with the ones on the ceiling, which is a pretty easy task compared to that, so I won't go into too much detail. That's about all the displacement work I'm actually going to do for this demonstration. It should hopefully give you an idea of how it works. I'm going to quickly paint the geometry and give some dirt patches here and there, but you can style your geometry however you wish. After a little bit more sculpting, I got it to a point where I was happy with it, and I was ready to move on to the detailing. Much like the sculpting of the displacements, I'm not really going to give you a whole lot of pointers on how to actually go about detailing your Hobbit hole. The remainder is very much about how you want it to look like. I'll only give you a couple of technical points that'll help you. One, most detailing that you do with brushwork, you should turn into Funk Details. You can do that by selecting your detail brushes and pressing Ctrl T. It'll automatically turn into Funk Detail and group all the brushes together that were selected. As a general rule, if you're wondering whether or not you should turn some brushwork into a Funk Detail, ask yourself if this brushwork is big enough to effectively block the user's line of sight. If it isn't, then you can turn it into Funk Detail. To give an example of what I turned into Funk Detail with my Hobbit hole, this is a screenshot of my finalized project, and this is a screenshot with all the Funk Details removed. As you can see, I Funk Detailed most of the stuff that was just smaller details or things that were off-grid, such as the arch outline around the door. 2. You can place props in your level by going to your Entity tool and typing in prop_static. There are 3 primary different prop types in Source: static, physics, and dynamic. Static places a prop that doesn't move, it just sits there and looks pretty. Physics props will create props that can be moved around. Dynamic props work a lot like static props, except you can tell them to perform animations if they have any. If you're trying to place a static prop, for example, in your level, and you boot up the game and you notice that the prop doesn't actually spawn in-game, it's most likely that the model you chose isn't compatible with that prop type. For example, a soda can is not compatible with prop static. You can get around this by going back to the prop and hammer and changing its entity type to prop_dynamic_override. This will essentially force it to act like a static prop, and since the models that you'd use this entity for don't have any animations, the only thing that those models will do is sit there and look pretty, just like your standard static prop. 3. If you find yourself applying textures to multiple brush faces that are next to each other, such as your Hobbit hole wall, and you find that they're not lining up correctly, as in you can see a separating line between when one face ends and another one begins, you can hold Alt while applying the texture to the new brush and that will fix the issue. It'll apply a wrapping effect which will override its standard texture application procedure. It's also good for applying textures at angles. You can see whenever I'm applying textures to the support beams up here at the top, I'm taking the texture from the bottom face of the brush and applying it to the sidewall with the wrapping technique to make sure that the texture perfectly aligns with the slope of this face. 4. You can apply decals to your level to give it a little bit more depth and help break up texture monotony. In your texture finder, filter for decals. This will give you a list of decals available for you to use. You can technically use any texture as a decal, but these are the ones that will actually look good. After you've selected a texture that you want to use as a decal, select the decal tool and place it in your 3D view. There's also the overlay tool, which is directly below your decal tool. This is effectively just a stronger, more powerful version of the decal tool, but it's more resource intensive. You'll use this one whenever you want to scale or rotate your decal, as the standard decal tool doesn't have that function. Since our map is taking place outside, we're going to want to add a light environment entity. If your map is completely inside and you don't have any skybox textures, you'll have to rely entirely on light and spotlight entities to light up your map. To make a light environment, select the Entity tool and place a light environment entity. Next, you'll want to Google Skylist. Select the first option that appears, and you'll get a benchmark for all the skyboxes available in the source engine, as well as defaults for light environment properties. Keep in mind that you can only use skyboxes from the game that you're mapping for, as well as the skyboxes from Half-Life 2, because those are packed into every source game. Find the skybox that you want, and copy and paste the values into your light environment entity. After you see what the lighting looks like, you can tinker around with the values until you get something that you want. As for changing the skybox itself, go to Map, Map Properties, and change the skybox texture name to the skybox name shown in Skylist. Hitting Apply will change the skybox texture on your next compile. That's more or less all the things that I could think of to make a Hobbit hole in the source engine. If you're looking for more resources and tutorials on how to use the source engine, I recommend checking the old source tutorial videos from 3 Clicks Philip, as well as checking out the channel tophattwaffle. He has very detailed and comprehensive videos about many aspects of the source engine. Both of their channels will be linked in the description. But that's the end for me, and I wish you all the best in your future mapping endeavors.